Hiya, I'm Sam, back with another iOS 10/Swift 3 screencast. In this 5 or so minutes of fun, I'm going to take a look at the changes in Foundation when you're working with Swift 3. As you migrate your code from Swift 2 to Swift 3, one of the first things you'll notice that you seem to have to remove the NS prefix from loads of the Foundation types. Although at first this appears like you've just renamed NSDate to date, NSDate components to date components, etc., that's not actually quite the case. In Foundation for Swift 3, a lot of thought has gone into whether particular types should be reference types or value types. There's no hard and fast rules for stuff like this, but there's quite a lot of guidelines. For example, a date is a value type, and that makes perfect sense. It is a value. It represents a point in time. But the new date struct wraps an NSDate reference type. Each time you assign a date to a property or variable, a copy is made of that underlying NSDate object. For performance reasons, this isn't the same for every single type, but the semantics are the same. For example, data is a value type, but you don't necessarily want to copy the entire chunk of memory every time you assign data to a particular property. In this case, copy on write is used, so the underlying NSData object is only duplicated at the point that you write to it. All of this happens behind the scenes, and all that you really need to know is that things that probably should be value types, in Swift 3 Foundation, they probably are value types. One of the types that now has these new value semantics within Foundation is date. So if I create a new date, a var now equals date, and then create another now which points to now. Now if this were a reference type, then when I change now, that would also change another now. I've now said now so many times, I'm really glad I chose that variable name. Now if you look here and look at another now, having changed now, then another now still retains the original value, i.e. it's copied when you first made that. Value semantics. Enumerations in C and Objective-C and hence Foundation are declared at the global scope and have really long, gnarly names. Now, in Swift 3, those enumerations are often nested within the type that they belong to. For example, the style enum on a number formatter. I'm going to demonstrate this with a number formatter. So I'm going to create one, let formatter equal number formatter, and I'm going to set the number style. In the past, this would have just been an enum at global scope, but here, then I go number formatter.style.currency. And if I then format a string for 123.32, you'll see that that comes out as $132.32. In actual fact, because of type inference, I don't need the number formatter.style, and I can just go straight in with .currency. This extends into the string enums as well, an example of which is the notification name. For example, if I go notification.name.nssystem timezone did change and take a look at that, and you can see that the raw value is a string. Now, one of the key things about notification name is that I can extend it with my own notifications, which I can do in the standard way. So if I do an extension on notification.name, and then within that do static let my magic notification equal a new notification.name, and then provide the raw value, which here I'm going to go for com.raiseware.myMagicNotification. Then I can take a look at that in exactly the same way, notification.name.myMagicNotification, and you'll see once again it has a raw value of the string that I provided. Another quick little thing here, and that's that class properties are now properties because the new static let. In the past these had to be static methods, but now we can have static class properties. Despite their name, index sets and character sets have never had the set algebra that you would expect from something called set. In Swift 3, index set and character set both conform to the new set algebra protocol. This means that you can perform all of the set operations you'd expect, things like intersections, unions, subsets, all that kind of great stuff. Both character and index sets adopt the set algebra protocol, so here I'm going to give an example using a character set. So for example, if I were to make a character set with the characters in the string AEIOU, then that would be a character set of just the vowels. Create a string that is my name, Samuel. That's what my mum calls me when she's telling me off. If I create a character set from my name, I can then find the intersection with the vowels, and that would result in a character set which contains just the vowels which exist in my name. Fairly standard set algebra. Another great introduction into Foundation across Swift 3 in many types is the introduction of initializers that have default optional arguments. What this means is you can create values and objects using an initializer, where in the past you'd have had to use the default empty initializer and then set some properties later on. A great example of this is within date components. Just to refresh your memory, in the past, if you want to create a date component, it has to be a var, and then you would go and set each of the properties that you want to create that date components object. Here, setting the 28th of March in 2017. Now, using this new initializer, then I can create that at init time, which means I can use let. Date components, calendar, time zone, era, year, month, day, hour, minute, second, nanosecond, weekday, weekday, ordinal, quarter, week of month, week of year, year for week of year, which is a bit of a mouthful. I can go through and choose whichever ones of those that I want, knowing full well that the default values for the ones I don't select will be nil, and it will create exactly the same date components object. Much nicer. Often, when you use NSData, one of the things that you might want to do is be able to iterate through the bytes within that NSData object. Although this has always been possible, it's never been that easy. Now, in Foundation for Swift 3, the data type conforms to various collection protocols. This means that you can iterate through the bytes in a data object and also randomly access them as well. I'm going to create a string with the contents hello ASCII string, and I'll call it ASCII. And then from that, I can create a data type using the data using .ASCII encoding. So now I've got 18 bytes of ASCII encoded characters. Now, because data has this new collection API, I can iterate through those. So for byte in data, and I'm just iterating through the bytes. I can print the byte value, which will just be a uint8 value. And then so I can check that it's all worked out as I expect. I can also convert that byte into a string using the ASCII encoding. Now, if you look down in the bottom there, you can see that it's pulled out each of the ASCII values, and then when you extract the string, you can see it's giving the right values. The collection API is also random access collection, so you can even go in and pull out particular bytes within that data collection. Obviously, I've not been able to show you everything that's new in Foundation for Swift 3. However, I think I've pulled out some of the core concepts which have then been used across the entirety of Foundation. I think this makes Foundation quite a lot easier to use, although beware that when this was introduced in WWDC, it was pointed out that this is the beginning of a journey. Expect new changes to Foundation as we move forward. I think this is a great picture of things to come. Cheers for watching. I shall see you again in another screencast, probably on Swift 3, maybe back to iOS 10. Who knows? Catch you later. Love you loads. Bye bye.